Hey y'all, so today I wanted to continue the series on the custom amplifier for Scott. I wanted to go over the preamp design, some considerations when selecting components and their values. We're going to be mainly dealing with the 12AX7 tube type, which is predominantly found in guitar amplifiers these days. So I want to go over, how to control bass response from the preamp by different values, how you can set the overall gain of a preamp stage. And by gain, I don't necessarily mean distortion, but how much the signal is amplified. And there are a few different components you can tweak to adjust that. So let's go over to the computer and I'm going to show you an online calculator and some schematics to give you an idea of what we are looking at. All right, so I wanted to start with the AB763 schematic and kind of show you the lay of the land on reading a schematic and what some of the parts are. So this tube right here, this is half of a 12AX7. A 12AX7 is a dual triode. So inside each 12AX7 is two gain stages, and triode tri is three: the plate, the grid, and the cathode. So for this to work, you need a plate resistor. Typical Fenders is 100K. This coupling capacitor. So this coupling capacitor will block the direct current coming here and only allow the AC guitar signal to come through. Then you need a cathode resistor. So pretty much all preamps and guitars are all cathode bias. You may hear that from power tubes, whether they're fixed bias or cathode bias, but generally speaking, all guitar preamplifiers, those stages are all cathode biased. And on this one, it has a bypass capacitor on it. And in a little bit, I'll get into what this does and how you can use this to tweak the settings on it. Now, you may see this resistor here is 820, but it's shared, so it actually ends up being relative 1.5K, which is typically what you would see. You do also have to have what's called grid leak resistor, and in this case, the master volume is being used for that. But you will see that like this 1 meg on the input stage is used for that as well. So looking at a different animal, the JCM 800, you see that this stage here, now it's kind of hard to read, but you got your plate, grid, and cathode here. Plate resistors up here, 100K, and down here it's just an 820, but there's no capacitor across here. The JCM 800 also has what's called a cold clipper stage. And that is this tube here, where you have your 100K plate resistor, 0.22 coupling cap here. But then you have a very large 10K cathode resistor. So this will bias the tube extremely cold and cause asymmetrical clipping where the waveform is not symmetrical on both sides, where it'll clip only one side of the wave. So on this calculator online, this is generally what we saw, where we've got the grid leak resistor here, plate resistor, coupling capacitor. This is the load on the tube, RG here. RL is the plate. And then RK is the cathode resistor. And then CK is the bypass capacitor. So when we get in here, this is already set for that Marshall input stage here, which is 100K, a 2.7K, and a 0.68K bypass capacitor. So this is the output here of the wave, and you can see that it's rolling off a lot of lower mids and bass, and that is due to the size of this capacitor here. So what if we change it to a typical Fender 1.5K cathode resistor, 100K plate resistor, and change this to a 25. Now you can see one of the things about Fenders that give them that bassier sound is just how much low end we now have in this amplifier. So you can see it does start to roll off a little bit right around the low E. In fact, this online calculator has that here. And you can see the overall gain of the amplifier. So one of the things I like to do is to use a smaller value, say 5 microfarads. And this rolls off more of the lower end here, but you still get to keep all of your mids and such. So now one other thing to kind of take into consideration is the value of the plate resistor and the cathode resistor. Now there's a ratio that I like to stick with that has been taken from amplifiers that I've been in, and several other boutique builders also use this particular ratio. Generally speaking, the higher value the plate resistor, the more gain you will have, and we'll see that here, but you will start to lose higher frequencies. So if we change this from 100 to 220 and then the cathode resistor to 3.3, so gain at 10 kilohertz here is 35.46, and now we change it. Now it's 37.42. So a pretty good increase in the amount of gain, but also you can change it to 150 and say 2.2 and 36. So you can see you can play around with these values to be able to get different characteristics of the preamplifier. So lastly, I want to talk about why you need that cathode bypass capacitor, or why you may not need it. So right now we have the typical Fender values here, and we see that we have an overall gain of 35.46. I can take this and put it to 0, and now we're at 29. So we've lost a lot of gain. However, you can see that the frequency response is completely flat. So this may be good for like a hi-fi type of amplifier, but when we're dealing with guitars, we do need the additional gain to push things through, like a tone stack or effects loops or reverb drivers, reverb tanks. So we need more gain, and more gain is more distortion, and everyone loves distortion. So that's one of the reasons why this is very important. So these are all things that I am taking into consideration when building Scott's amplifier. If you guys have any questions, please put them down in the comments, like and subscribe. Thank you all.